Alright, welcome. So this is 3.8, slopes of parallel and perpendicular lines. So our objective is to relate slope to parallel and perpendicular lines. This time, in 3.7 we talked about how to graph certain lines. Now we're going to have two lines and we're going to tell whether they are parallel, meaning that they never touch, or if they are perpendicular, meaning that they come and make 90 degrees. Okay, so make sure you have that at the top. Alright, so we are going to write this right here. Make sure that you write slopes of parallel lines. You write everything inside the box. So, slopes of parallel lines. How do we know if lines are parallel? If two non-vertical lines are parallel, then their slopes are equal. Also, second point, if the slopes of two distinct non-vertical lines are equal, then the lines are parallel. Any two vertical lines or any two horizontal lines are parallel. So the biggest thing there is if they have the same slope, then they're going to be parallel. Or if I have two horizontal lines or two vertical lines, then they are going to be parallel as well. So that's how we tell whether or not the lines are parallel. Okay, so let's go on to our next page, and we'll go down here, and we will copy everything in this one. So how do we know if lines are perpendicular? So it says if two non-vertical lines are perpendicular, then the product of their slopes is -1. If the slopes of any two lines have a product of -1, then the lines are perpendicular. Any horizontal and vertical lines are perpendicular. So how do we know if lines are perpendicular? If their slopes, if we multiply them together and we get -1, then they are perpendicular. And if you could see though right here that this statement right here, and use this one, and this right there, that is my converse right there. All I did was I flipped the if-then statement, and both of those are true. So if you see, that's basically what we're doing there. Okay. All right. So make sure you have everything in those two boxes written down, and we will do a few problems. All right. Problem number 1. Make sure that you write out the problem. And make sure that you also draw the picture, so you won't get credit if you don't have the picture drawn. So the problem says, are lines 1 and 2 parallel? Explain. Well, if I look at these, they look parallel, right? They look like they don't touch. But I have to tell for sure whether or not they're parallel. And how do I know that? Well, we just wrote down what are parallel lines. Parallel lines are lines that have the same slope. So if I find out that they have the same slope, then these two lines would be parallel. So how can I find this out? I can find slope two ways. So remember, my slope, I could do the change of y over the change of x. That could be one way to do it. So I have 2 points. I can find each of the slopes of the 2 points and check them out that way. Or another way, usually when we have a picture like this, it's a lot easier if we can just do the rise over run. The rise over run. So usually with the picture it's a lot easier. All we have to do is just count boxes, right? We like that. So we start from the left and we go to the right. So starting from the left, from this one, I am going to go down 1, 2, 3, 4, 5, 6, 7. So I went down, this is line number 1. I went down 7, so down would be a -7. And then I go right 1, 2, so that'd be +2. My slope for my line number 2 is I start here and I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went down 9. And then I'm going to the right. 1, 2, 3. I went over 3. So it's best to simplify these if possible. So line 1 right here is still -7 over 2. But this line 2 right here we can simplify. 3 can go into both. This would be -3 or -3 over 1. If I'm looking at these two don't have the same slope, which means that they are not parallel. So I would say line 1 is not parallel to line 2 because they have different slopes. So in order to be parallel, they have to have the same slopes. These ones don't, which means that they will eventually cross. Okay? Alright. to our next one. Alright, problem number 2. Okay, so this one says, what is an equation of the line parallel to y equals negative 3x minus 5 that contains negative 1 comma 8? So we need to write an equation. So if I remember, what makes lines parallel? Well, in order to be parallel, they have to have the same slope. So I see right here that the slope in this case is negative 3. So it's going to have that same slope. Remember, the slope is m is right in front. So I can write an equation this. And what equation can I write? We have two of them that we know. We have our slope-intercept form and we have our point-slope form. Well, in this case, we know what the slope is and we know a point on the line, so we should use our point-slope form. So our point-slope form is y minus y1 equals m times x minus x1. Now we just found the slope. The slope right here is this m, so we know that this is going to be negative 3. They're going to have the same slope. Now what I like to do with my points is I like to label it. So I make sure I label this x1, y1. So I know exactly where to put that. I'm going to put that right where it says y1. So this one just says y, so I'm going to write y minus y1 is 8. Then this is going to be x minus negative 1. So make sure that when you're putting in the negative right there, there already was a minus sign. So now I have a double negative. Double negative right there is become a positive. So if it just asked me to write an equation, that right there would be acceptable. But a lot of times we like to put things in our slope-intercept form. It's a lot easier to be able to graph it in that form, and it's a lot easier to be able to tell what the y-intercept is. So how can we put this in the slope-intercept form? Well, we can first, let's do a red pen right here, we can distribute the 3. So if I distribute the 3, that's going to give me y minus 8 equals negative 3x minus 3. And now all I got to do is get my y all by itself, so I'm going to add 8 to both sides. And this is going to give me y equals negative 3x plus 5. So that is now in my slope-intercept form, which again, it's really easy to see what my slope is. That's negative 3 right from the x. But I can also see if I graph this, that's my y-intercept. Okay, perfect. Okay, remember, in order to be parallel, you have to have the same slope. Alright, next one. Alright, my last one, number 3 right here. So make sure you write up the problem. It says, what is an equation of a line perpendicular, coming to 90 degrees, to y equals 1/5 x plus 2 that contains the point 15 comma negative 4? So this looks exactly like our last problem, just instead of being parallel, we want to know perpendicular. So remember, we talked about if lines are perpendicular, we need to have the slopes, the two slopes of the lines, when we multiply them together, they're going to equal negative 1. Okay, so how can we figure out what number that is? Well, it's really easy actually. All we need to do is take the, what we call the opposite reciprocal. The opposite reciprocal of our slope. And our slope, remember in this case, is our m, which is right in front of that x right there. Okay, so if I have 1/5 right here, 1/5 right here, do a little arrow, 1/5. Now, what could I multiply 1/5 by to equal negative 1? Well, all we have to do is take the reciprocal, which is my fraction flipped upside down. So now this is going to be 5/1, and I have to take the opposite. So if it was a positive, now it's going to be a negative. If it was a negative, now it's going to be a positive. So I have my opposite reciprocal. So now that I have my slope, right? All I need to do is take the slope, I take the opposite reciprocal, positive, it's negative, and I flip the fraction. Now that I have that, I can just plug this into my formula. And what formula should I use? Should I use my y-intercept formula, or my slope-intercept, or my point-slope? Well, I have a point, and I have the slope now, so we can plug that into our point-slope. So we're going to write y minus y1 equals m times x minus x1. Okay, so we just found out that the slope, that the product of it, when I multiply it, will equal -1. That was -5, or -5/1. So my slope is going to be -5. I have x minus, and all I have to do is plug this point, a point on the line. Again, I would label it x1, y1, so I know exactly where to put it. So it says y1 is going to go right here. So remember, there's a minus sign right here, -4. So when I put a negative in, I have this double negative now. Now it's going to become a positive. So in this one right here, I have minus, I plug in the 15, I have 15 right here, and it just asks to write an equation. So that right there would be an equation. Okay, a lot of times we like to put it in our slope-intercept form because easier to graph, easier to see where the y-intercept is, but we'll leave it right there for that. Just remember, parallel lines, they are going to have the same slope. You're going to have perpendicular lines, means that you need to have the slopes, when you multiply them together, the product will equal -1. How do you know what that number would be? You take the opposite reciprocal, meaning if it's a positive, now it's a negative. If it's a negative, now it's a positive. So if you take the opposite reciprocal of the slope, that will give you the slope that will make it perpendicular. Sounds good? Alright, see you guys.